Good morning and once again welcome to my YouTube channel, Pearson and Excel International Maths by Mr. Kamoto. And today I want to introduce a very important part of this topic, which is differentiation in pure mathematics 4. And we are on page 54. And I want us to just discuss something to do with implicit differentiation. And implicit differentiation is when you differentiate when the functions are mixed up. What do I mean? Sometimes equations are difficult to rearrange in the form y is equals to function of x, whereby you have y on the left hand side and all x's on the right hand side. That way you will differentiate with respect with, you will simply talk about dy dx. Or x is equals to a function of y, and this way you will differentiate x with respect to y, dx dy. And if that cannot be done, if you cannot rearrange terms when we have y and x on either side, you can sometimes differentiate these equations implicitly without rearranging them. And this is what I want to say. In general, if you have the d dx of a function that is having y, the differential with respect to x of a function that is having y, note that this function is not having x, yet we are differentiating with respect to x. This one gives you the derivative of the y itself, the derivative of y itself. And please remember, because there is no x here, remember to tell us it is dy dx. We were to differentiate y with respect to x. Tell us that. You know, when we have, when you want to differentiate a function in terms of y, first get the derivative of y, and then remember to indicate that after all we were having to differentiate y with respect to x, but there was no x on the function. So that is one rule. That is one thing that you're going to talk, and this one is from the chain rule. This one is actually from the chain rule. We will see how. The following two specific results are useful for implicit differentiation. That a differential with respect to x of y which is raised to power n. This one is always n, y, n minus 1, the differential of the y function. And then dy dx. Why are we doing this? The differential of the term that is having y, which is n, y n minus 1, and then the differential of the whole thing, the differential the differential of the whole thing, d dx of y raised to power n is actually supposed to be dy dx, the change in y over the change in x, meaning that it is, we must indicate that we were not having x. So according to chain rule, this differential is specifically for this part, and this one is there for the whole, because everything, the whole thing, we are supposed to have dy dx, the differential of y with respect to x, the way we know it. So when we get to the solution, we are having the differential of the y part only, and then multiplied by the differential of the whole thing, which is basically dy dx. And this is reminding us that our function did not have x anywhere, yet we were differentiating with respect to x. So we have to indicate that the differential of the whole thing now becomes dy dx as far as chain rule is concerned. You may also have something else like the differential with respect to x of xy, which is now because this one has x and we are differentiating with respect to x, the differential or with respect to x here becomes so easy because we have y. Y is the derivative of xy because the power 1 here just gets finished and or disappears, plus the differential of y, which is x, again with respect to y, and of course the differential of the whole thing here multiplied by dy dx. Only when we are differentiating y, we have to keep remembering our differential was with respect to x, and that is why we have dy dx after every differential of y. When we differentiate implicitly, equations uh, uh, when we differentiate implicit equations, your expressions for dy dx will usually be given in terms of both x and y. And I want us to just, I just want us to go to example 3, but implicit differentiation is simply about this. When it is difficult to rearrange the functions normally the way we do, y on the left, x on the right, then we can differentiate in their original positions. But remember to undertake implicit differentiation. Only when we come to differentiating y, which we easily differentiate, remember to continue to keep reminding us at that particular point that dy, it is our function should be differentiated with respect to x. By chain rule, then we get x. For instance, this one, dy dx of the whole thing. Fine, let us look at example 3 and we see what happens. Example 3 is find in terms of x and y where x cubed plus x plus y cubed plus 3y is equals to 6. Find in terms of find dy dx. So we are supposed to find dy dx. That's the question. The question is find dy dx in terms of x and y where x cubed plus x plus y cubed plus 3y is equals to 6. And dy dx with respect to x, this is x term, so it is very direct to differentiate x term, 3x squared. This is another x term plus 1, differential of that one, but this is a y term, so plus 3y squared. But remember to remember by chain rule, now this one we have to differentiate y cubed, which is 3y squared, and remember to talk about dy dx. Remember to remind the world that as much as we are actually differentiating y with respect to x, we have a function that does not have x here. So we differentiate it and remember to indicate it is after all dy dx. So plus 3 again dy dx is equals to 0. And we know very well that if we talk about what? If we talk about dy dx, because we are finding dy dx into bracket 3y squared plus 3 is equals to, we can bring everything else across, is equals to minus 3x squared minus 1. So, in a nutshell, we are saying dy dx is equals to minus 3x squared minus 1 all over 3y squared plus 3. And that is just what we have. If you like, probably you can talk of minus 3x squared plus 1. You just get minus outside everything over 3 y1 plus y squared, or y squared plus 1. That is just like it, and that is our dy dx for you. Please remember implicit differentiation. Every time we don't have x, remember to remind everybody that even though I have differentiated y normally, was supposed to be the differential of y with respect to x, and that is just like what we need to understand in implicit differentiation. Remember the three rules. Remember the three rules. There is one rule there. If you ever differentiate a function that does not have x, differentiate y and remind everybody it was supposed to be dy dx. Well, get to my YouTube channel, subscribe widely, and of course, let's share and work together. All right.